All right, let's try this question. It's a type of question called the common ion effect. Yes. So I want to see how much CaF2 I can dissolve into a solution that already has NaF in it. Yes. Now, NaF is going to give me Na plus and F minus. And Na plus isn't coming into play here because there's no Na plus in the thing that I'm interested in. However, the F is going to cause me a problem because there's already F in the beaker when I'm trying to drop CaF2 in. So this original amount of F is going to hamper how much of this will dissolve. So it's saying that this concentration is 0.025 molar. So this concentration, all sodium compounds are 100% soluble. So this one's going to be 0.025 molar, and this is 0.025 molar. So now I'll write the reaction for the one that I'm actually interested in. CaF2, yes, gives Ca2 plus and 2F minus. Yes. So, oops, just a little. Perfect. So how much of this is going to dissolve? We could say X, because I'm not sure. How much of this am I going to get? X. Now, how much of this will I have at the end? Well, I'm starting with this much, and I'm going to get X more. I would get 0.025 plus X. So this would be my final row. If I'm interested, if you're not sure about that, go ahead and make a chart with initial. I might as well do it now. So let's do it. Initial change final. Initial. It doesn't really matter about this guy because it's a solid. Initial, I have 0 here. I got 0.25. How much will I make of this? X and X. X. 0.25 plus X. Yeah. So that's how I'm getting that that line that I wrote there. So now I'm going to write the formula for KSP is going to be Ca2 plus and F minus squared. KSP is, I wrote it down up here, is 4 times 10 to the minus 11 is equal to X times 0.025 plus X all squared. Now, if I go ahead and expand this, I'm going to get a quadratic equation, and that would be ugly. So what I'm going to do is I'm going to make the approximation. The initial concentration divided by KSP. Look at the size of KSP. It's minuscule. This thing divided by that is huge. So it's going to be much, much bigger than 1,000. And therefore, X is small. Yes? So therefore, 0.025 plus X is pretty much equal to 0.025. Yes? So I'm going to go back over here now. Yes? And this is going to become 4 times 10 to the minus 11 equals X times 0.025 squared. Yeah? X equals 4 times 10 to the minus 11 over 0.025 squared. And I'm going to get 6.4 times 10 to the minus 8. So the question says, what's the solubility of CaF2? Well, how much CaF2 am I going to dissolve? X worth, right? The ratio is 1 to 1 to 2. So I figured out X. So therefore, Therefore, 6.4 times 10 to the minus 8 moles per liter will be the solubility of CaF2. That's it. So really, it's a question where you can make a chart if you want. I know KSP questions, I kind of said, if you remember, we don't necessarily need to make a chart, but with this common ion effect, you might find it useful to make a chart, or maybe now at this point, you can just see what this final line is going to be. And there you go.